Today I will be proving the generalized 2 lemma, and what it says is that if I have a space y and another x, let me move it down a little bit. I have a space y and a space x, and I have a compact subspace of x, a compact subspace of y. I'll call them A and B. If I look at their product, right, that's their product right there, A cross B, and I find an open subset containing it, I'll call N, then there exists an open U. So this is going to be an open U in Y, or V in Y, and an open U in X, such that their product completely contains A cross B and is inside of N. So, the thing says is that if A be compact, A cross B subset N open, there exists U V open such that A cross B is a subset of U cross V is a subset of N. That's what the generalized 2 lemma says. So now, let's prove it. Proof. I'm pretty sure it has to be in a Hausdorff space. Okay, so the first part of the proof is that for all A, B, or for all A in A and B in B, right? Or let me write it like this: A cross B in capital A cross capital B. There are open sets. There exist open sets around them, right? UAB, VAB, such that A B is an element of UAB cross VAB, and is going to be a subset of N, because N is open and we have the basis of all the open sets. Okay? So now, what I'm going to do is I'm going to say fix A an element A. Then, I'll call it A naught. Then, V A naught B for B in B covers B. By definition of compact, there exists a finite B1 to Bn such that VA0 BI covers B. Then say V prime, or say V prime sub A naught is going to be equal to the union of these V A naught BIs, and U prime A naught is going to be equal to the intersection of U A naught BI. Okay? So, then do this for each A. And also, because this is finite, the intersection is finite, the product is open. Right here, arbitrary unions are open. Then for each A and A, you find that U prime A covers A. Then there is a finite subcover. I'll call it U prime AI covers A, right? Then take V double prime to be equal to the intersection of all of these V prime A's for A and A in this a V prime AI and U double prime to be equal to the union of the U prime AI. Okay, both of these are going to be open, and this right here is going to contain A, right? How do I know this is going to contain B? Well, because each of these VA zeros contains B because this is a cover, right? This contains B because each individual contains B, and it's also open. Now, how do I know that U double prime cross V double prime is a subset of N? Well, this is because each individual U A0BI is a subset of N, and I'm taking the intersection. Each individual V A0BI is a subset of N, right? Because you can see here that their cross product is a subset of N. Here is a subset of that cross product in a sense. So each individual one, their cross product is in N. Therefore, all of these are just making subsets that are also going to be in N. So, yes. And thus we're done. So, what is a visual standpoint of this proof? Well, the visual representation of this proof is that I have my two spaces X and Y. I have A and B, right? Right? So this is my two compact subspaces. Basically what I do is at every single point, well, I'm going to have an open subset containing it, right? And then around each of these points, I'm going to find the box around it. Just find the box around it, completely contained inside of N, right? Do that at each of these points, right? Maybe one on the edge, right? Okay, then I look at this open subset down here for each individual one, right? And you just bring each one down, right? You also do it along here. I'm just going to eyeball it. Also one right there. And one right above it. There. So there we have a bunch of open sets at each individual point. Basically, I just pick a bunch of these open sets and allow them to cover A down here. And I pick a bunch of these to cover B, right? And then I just bring them back up onto here. And then what I do is I union all of them down here, and I union all of them up here in a sense, and then make that the big open set containing it inside of N. And that's basically how this works, even though my picture is the worst possible.